So, dear students, in this video, we will be talking about operational amplifier as voltage follower, and and the condition that we achieve by making use of operational amplifier as voltage follower is that the output voltage of the arrangement is proportional to the input voltage. And since we are making use of an operational amplifier, and output of this arrangement is same as that of the input, and at the same time we are dealing with the device which has infinite input impedance. Ideally it's very large, and output impedance is small. For ideal operational amplifier, it's zero. So, uh, so, so this kind of arrangement is very useful in impedance matching, and this impedance matching uh, it is exploited by electrical engineers in order to have the impedance matching in such a way that there is a maximum power transfer. So to to go in the details of this operational amplifier, making use of operational amplifier as a voltage follower, we have to draw its circuit. And we have the operational amplifier, and this is inverting terminal, this is non-inverting terminal, and here we have a signal, and then we have ground, and this is the output. And I think we have already discussed non-inverting amplifier, and and we have obtained an expression for voltage gain for non-inverting operational amplifier as 1 plus RF by RI. So this is what we have already discussed in the previous video, and here we have a signal that we are subjecting to the non-inverting end of this operational amplifier. Then we have we have the feedback resistance, and that is RF. And let us assume that this resistance is Ri, and this is grounded here. Okay, so we can immediately think about a junction. Suppose we choose this as a junction, and here we have this signal voltage. Instead of S, I will call it VI. Now VI refers to the input signal. Now, what is the necessary condition for an operational amplifier with extremely large impedance in the input circuit and extremely small impedance in the output circuit? So in order to make things consistent, this feedback resistance resistance should be extremely it should be almost zero. So if we want this resistance to be equal to zero, we have to short this. The best way is to short it. And the input resistance here, we have the input resistance Ri, and to make Ri maximum, the best possible way is to keep it open here. So to keep a gap. So if we keep it open, we are confirming the condition for for extremely large input impedance, and if we keep RF, if we short it simply, that will give us minimum possible resistance in the output circuit of this operational amplifier. So how would this circuit look like? Is if I will redraw this circuit, we will have an operational amplifier, and this is the inverting end, and then here you will have the output. So this is V out, so this is the inverting end, but we are giving signal to non-inverting end. All right, this should be the case, and we can immediately think about the gain, because basically it was an arrangement of non-inverting operational amplifier, and we are aware about that the gain is 1 plus RF by RI. Now RF is 0 and Ri is infinite. So AV, the voltage gain, should be equal to 1. But what is the original definition of voltage gain? Voltage gain is V out by V in. So V out by V in must be equal to 1. So we can say that V out is equal to Vi. So this will be the final configuration of operational amplifier as voltage follower, and the necessary outcome of this arrangement is that the output voltage is exactly same as that of the input voltage. But what is different? What is making this kind of circuit important is that we have large input impedance and we have extremely small output impedance. And as I said in the beginning of this lecture, that this uh, that we look for impedance matching situations. So for best matching, we have maximum power transfer. So that's the job of an electrical engineer, to exploit such kind of things in technology. But here things are clear that the output voltage is following exactly as how the input voltage is being executed on the operational amplifier. So this should be uh, the case, uh, to realize and understand that how this voltage follower circuit executes and how it works, and we are able to demonstrate that the output voltage is exactly same as that of the input voltage.